Hello everyone, welcome to my channel Physics with Bhatt. To learn concepts of physics, subscribe this channel and press the bell icon button to get notified for every new video lecture. Hello everyone, hope you all are doing well. Today once again I am with you in the same series of video lectures for atoms. In previous video lecture we discussed about the experiment executed by Geiger-Masten and the Rutherford atomic model. Very important. There are two very important parts, or you can say there are 2 points of Rutherford atomic model. The first is entire positive charge is concentrated on the nucleus, and the second one is all the electrons are revolving around the nucleus in their respective orbits. So today we will talk specifically about the orbiting electrons, the electrons which are orbiting around the nucleus, how it is happening and what should be the velocity and radius of the orbit that we will discuss here. So I brought today again the very important part of this chapter. This is orbiting electron. So to understand this, we will consider the Rutherford atomic model's point once again, that according to Rutherford, electrons are revolving around the nucleus in their respective orbits. So when it comes to the revolving motion or circular motion of any object, then we know that the centripetal force is necessarily required for such kind of motion. So which force is responsible here for the centripetal force? We know that the nucleus is positively charged and electrons are negatively charged. So the force between the nucleus and electron is electrostatic force, and this force is attractive in nature. So this force provides the necessary centripetal force. You can see here the necessary centripetal force required is provided by the electrostatic force between electron and nucleus. So let's see how does it happen and how these electrons are revolving around the nucleus. Just try to understand by this diagram. This is the atom. In this atom, this is nucleus having the positive charge Ze. Around this nucleus, electrons are revolving in their respective orbits. So just see, this is the electron revolving nearest to the nucleus. Another one is revolving in its orbit, and let us consider one more. So we have taken 3 electrons here revolving around the nucleus in their respective orbits. These are electrons. So their orbits will not change. They will remain revolving around the nucleus in the same orbit until and unless their energy is not changing. Now we will try to find the expressions for radius, orbital radius of electron, and velocity of the revolving electron. So as I told you in the beginning of this lesson, that centripetal force required for revolving motion is given by Fc is equal to mv square upon r, and this force is provided by electrostatic force. So we will write the expression for electrostatic force also. Electrostatic force is given by F E is equal to K Q1 Q2 upon r square. Here Q1 is equal to E and Q2 is equal to Ze. So Fe is equal to K into E into Ze upon r square. So these two forces would be equal because they are providing the centripetal force. So mv square upon r is equal to kZe square upon r power is cancelled. So mv square is equal to kZe square upon r. You can see here what we have done. This is the centripetal force and this is electrostatic force, and this electrostatic force is providing the centripetal force. Therefore mv square upon r is equal to kZe square upon r. So mv square is equal to kZe square upon r. This is the important expression. Using this we can find the expression for radius and velocity as well. So if we use this formula, mv square is equal to kZe square upon r. So r is equal to kZe square upon mv square. This is the formula for orbital radius. Also mv square is equal to kZe square upon r. So v square is equal to kZe square upon mr. So v is equal to under root kZe square upon mr. This is the formula for orbital velocity. So in that way we could find the radius as well as velocity. This is the formula for radius, orbital radius. Everything is constant here except the velocity, and this is the formula for velocity. So radius is given by r is equal to kz e square upon mv square, and v is given by kz e square upon mr. Then we can talk about the energy of orbiting electron. You know that there are two types of mechanical energies, potential and kinetic energy. When electron is revolving around the nucleus, then it will be having these two energies, potential and kinetic, and the sum of these two is the total energy of a revolving electron. So total mechanical energy is sum of potential and kinetic energy, that is E is equal to U plus K. Potential energy is given by minus K Q1 Q2 upon R. This is electrostatic potential energy. This formula is used. Here Q1 is E and Q2 is equal to ZE. If you replace these two for Q1 and Q2, you will get U is equal to minus K E into ZE upon R. That gives us U is equal to minus KZE square upon R. Likewise, we can find kinetic energy also. Kinetic energy is given by K is equal to half mv square. Then total energy E is equal to minus KZE square upon R plus half mv square. Now we have to replace for mv square, and mv square is equal to KZE square upon R, that we had discussed in the same lecture. So if we replace this, we will get E is equal to minus KZE square upon R plus half KZE square upon R. If you solve this, we will get E is equal to minus half KZE square upon R. So this is the total energy of orbiting electron. By using this formula, we can find the total energy of revolving electron. If you compare this total energy with these two parts of the energy, potential and kinetic, then you can see it is half of the potential energy and negative of the kinetic energy. So we can conclude E is equal to U by 2 and E is equal to minus K. This formula is very helpful in solving the numerical problem. So in that way, in this video lecture, we discussed about the revolving motion of electron around the nucleus, which force is providing the necessary centripetal force, what is the formula for orbital radius and orbital velocity, and what is the total energy of the orbiting electron. I hope this will help you to understand the revolving motion of electron around the nucleus. We will meet very soon in the next video lecture. Till then, keep watching, keep learning.